A linear function is a function whose graph is a line. Linear functions can be written in the slope-intercept form of a line, f of x, which is equal to mx plus b, where b is the initial or the starting value of the function when the input x is equal to 0, and m is the constant rate of change or the slope of the function. The y-intercept is at 0, b. For example 1, we're going to use a linear function to find the pressure on a diver. Now the pressure P in pounds per square inch, PSI, on the diver in figure 4 depends on her depth below the water surface, D, in feet. Now this relationship may be modeled by the equation P of D, which is equal to 0.434 D plus 16.696. We want to restate this function in words. Now recall, what is the slope of this equation? Well, we can see that this is going to represent the slope, and we can see that this is going to represent the y-intercept when the value of D is 0. Now, to restate the function in words, we need to describe each part of the equation. We can say that the pressure as a function of depth equals 434 thousandths times depth plus 14 and 696 thousandths. So basically what we did is we just repeated what this equation looks like in words. We said again that the pressure as a function of depth, what's inside the parentheses, okay, equals 304 thousandths times the depth plus 14 and 696 thousandths. Now the initial value, 4.696, is the pressure in PSI on the diver at a depth of 0 feet. So that means that at 0, then we can see that this number is going to be 14.696. So again, this is representing the depth, and this is representing the pressure, or PSI. Now, again, which is the surface water. Now, again, we talked about the slope up here. So the rate of change, or the slope, 0.434 psi per foot. This tells us that the pressure on a diver increases 0.434 psi for each foot her depth increases.